do this is if I want an in-order traversal, I pretend that I'm a boat starting right here, and I only write down the nodes that are above the boat. Okay, I only write it down when my boat, when a node is right above my boat, and I hug all of these little sandbars or reefs or whatever. So watch what happens when the boat moves around. Ready? Okay, there's no node above me, no node above me, no node above me. Ah, there's a node above me, so 29. Notice I'm doing the in-order traversal. So I write down that node because one is above me. And then again, I'm hugging the shore here up. Now 41 is above me. I keep hugging the shore, 6 is above me. Keep hugging the shore, 17 is above me, right? Hugging the shore, 81, 9, 40. That's it. So I've gathered all the numbers, and to make it easier, I just have to, in this case, look and see that, that my finger is on the bottom of the node. If my finger is below a node, then I know I can write it down. Okay, so this is the trick to make life a little bit easier if you're asked to do this. Now notice this is a binary tree. It doesn't have to be a binary search tree to do the traversal on it. But if it were a binary search tree, then the numbers would in fact be a sorted list, right? This is not. Make sense? So I have to run my very time-consuming animation in PowerPoint just because I've spent the time on it. So here's my animation in PowerPoint. Yay. Okay. All right. Yeah. Don't try to do this at home. It's not worth the time. All right. Any questions about those orders? This is just a traversal trick to make life easier. All right. Cool. All right. Now we got to change topics, but let me just make sure everybody's okay. Does anybody have questions about these traversal mechanisms, how you do them with the tricks? You will maybe on a test be asked, here's a tree, tell me the order in which something happens. That could be an exam question, right? I give you this tree and you traverse it in the 3 orders and write down the numbers as they would come out, or it doesn't have to be numbers, right? It can be strings, can be anything, right? Any questions there? Okay. All righty. So then the one other thing that I want to talk about today is a Java thing that has nothing to do with this trees or anything else. It's just a Java idea. It's a programming idea, and it's something that, as I said, you'd think that being halfway through our second Java course, our brains would be really, really clear on this. But it's amazing that they're not, right? That when we write our code, we're going to write erroneous code a lot of times because we really don't understand this as fully as we should. So here is the idea, okay? I want you to please look at this code and tell me whether when I print this thing, when I run main, I want to know whether, you know, we know that what's going to be printed up here is A equals, and then whatever this thing is, which is A. So right here on this line, it's going to say A equals 3 and B equals 4, because that's their values here, right? That's the values that we will get here. The question is, when we get to this line and we've called the swap, the question is, what is printed here and what is printed here? Because I've called this swap int, it's created a temp variable, it's swapped the values of those things. So the question is, when I get to this line with this printf, does it print 3 and 4, or does it print 4 and 3? Sarah says they're the same. Okay, why are they the same? I've clearly swapped them, right? I called the swap code. So to a beginner, maybe I think that those two things will have swapped, but the answer is they have not swapped. Why?
Because they're integers and not like references to an actual object.
Okay. So yeah, and that would be the common thing that we think of is, oh, of course they're primitives, right? They're primitives, so it's just passing a copy. So what happens down here? Let's talk about it technically. What happens here when I say int temp equals x? Great, I've got a temp variable and it has a copy of the 3 in it. But when I do this, what am I actually doing here? What is x in this context? Is it any kind of reference to something that happened up here in the calling program?
So it's just a new variable.
It is exactly a local variable that we created right at this instant, right? When you called this thing, it's a local variable that got its value when the call was made. So it became 3, so x contains 3, but when I'm saying x equals y, when I'm doing these things, all I'm changing is my local variables, right? I'm changing my local variables. I'm not changing anything about the caller's version of anything, okay? It copied down the 3, it copied down the 4. I can mess with my local copies all I want. It does not change the caller one bit, okay? The caller is unaffected, okay? Everybody see that? Everybody understanding why that's the case? Okay, so that one's an easy one, right? That's the softball one because I gave you primitives, right? So now let me change the picture a little bit and see if you feel differently about it. So now I have student A, that's Chris, and student B is Lupe. So if I print here, right, student A, this is going to be Chris, and this is going to be Lupe, right? So Chris is going to be here, Lupe is going to be here. That's great. Question is, when I get down here, are they different or are they the same? Because the argument last time was, well, they're primitives, so of course it's not going to work.
Still the same.
They're still the same. They're still the same. Okay. That might surprise us a little bit because all of a sudden I changed the rules a little bit and I said, oh, these are objects. So these are references, right? These are references. So when I pass Chris and Lupe down here, this X is a reference to the actual student object, right? This X is in fact a reference to this student object, and the Y in fact is a reference to this student object. So why is it that they didn't swap? Because you can write this code and stare at this a long time and your brain will tell you they're references, right? I'm passing by reference. Well, actually, this is not true, right? It's not true. You might say that in your brain. It's passing by reference. Nope, right? That's maybe what your brain is telling you, but it is not true. Why is it that we can't make a change here that's affecting the caller? Because clearly I make this variable and I reassign them. I have swapped them in my thing. So why didn't they swap for the caller?
But you never changed the references of student A and student B.
Right. Why is it that I couldn't do that? I tried. I thought that's what I was doing. But why can't I do that?
I'm not 100% sure, but I feel like you just assigned new references to the same object, right? With X and Y.
That's right. You assign new references to the same object. So another way to think of it is, you know where the Chris student is in memory. You know where the Lupe object is in memory. You don't know where the student A variable is and the student B variable is in memory. See what I mean? You know what those things pointed at because when they passed the reference, it copied it just like it does with a primitive. It copies what's in that memory address. That memory address just happens to be an address, right? That memory, that little variable contains an address, so it copies the address. So we've passed where Chris lives and where Lupe lives. Now, if our task was to make differences in the data to actually change the student objects, that would be fine, right? We could do that. But you don't know where this or this are in memory. You actually have no access to them because you weren't given that information. You were passed what they contain, which is a pointer to something else. You were passed a little clue as to where Chris is and where Lupe is. You were not passed the address of where student A variable is in memory and student B, okay? So what happens down here The thing that we have to understand is, even though we may think we knew otherwise, there is nothing you can do inside a function that will change the caller's reference. You can't ever make the caller point to something new. You can change the thing we're pointing at. Like it can tell me what student it wants me to update, and I can update that student. That's not what we're talking about. We're talking about, can we make the caller's variables point to something new? And the answer is no. We can't. We can't in Java. Why? Because Java passes by copy. Java passes by value. It does not pass by reference. When we pass a reference type, what's happening is it's copying the address, but that's the same issue. It's still copying whatever's in that little memory location and putting it in here, just like it did with the primitive. Happens that is in an address of where the thing is. But we do not in Java pass by reference. We only pass by copy. Everything in Java is passed by copy. So nothing that a function can do can change what the caller's references pointed to. Nothing. Can't be done. Okay. Still, what we're doing here is we're messing with our local variables. You can mess with our local variables all you want. It has nothing to do with A and B up there. Now, you could be clever and say, you know what, I'm going to take the student ID out of the one and put it in a temp variable and the student name. Like I can go take all the contents of the objects out and then try to put them in the other spots. Yeah, but that's different, right? That's changing the contents. You're still not pointing at new objects. Okay. Any questions about that? Want to make sure you're clear. It seems like a straightforward thing in some ways, but again, a lot of students will write code like this and then stare at it for a really long time, trying to figure out why it won't work. Like, I know that's a reference. I know that's a reference. Yeah. Okay. Any questions about that idea? We're going to talk about what we do about it, right? Because obviously there's a solution. But you can't do this in Java. Any questions about that? You can change your local references, but you can't change their references.